Hello guys, kumusta? It's been a while and I hope all of you are doing fine and coping well with your online classes. Today, I would like to directly proceed to our lesson because this topic is quite long. Let me just share my screen. Today, we are going to discuss two system design decisions in operations management, and these are process selection and facility layout. Here are the learning outcomes for this lesson. After completing the study unit, you should be able to number 1, demonstrate your understanding of the different types of processes. Number 2, demonstrate your understanding of the different types of layouts. Number 3, contrast and differentiate the various types of processes. Number 4, contrast and differentiate the various types of layouts. Number 5, demonstrate how to design product layouts using assembly line balancing. Number 6, demonstrate how to design process layouts. We all know that processes convert inputs into outputs. This is the core of the operations department, since majority of the activities under this department involves creating value by converting various inputs to the desired output. Choosing or selecting the process type have strategic significance. Its impact goes beyond operations management and it affects the entire organization. Different process types have different capacity ranges, and once a process type is functioning, changing it can be difficult, time-consuming, and costly. At this point, I hope you have already seen the video about how soft drinks are produced. As you can see, the process is so complicated from the bottle molding process up to the final packaging of the soft drinks. Perhaps it cost millions of dollars to set up that state-of-the-art system consisting of several sub-processes, machineries, and equipment. And once it is decided and implemented, it is not easy to just change the process overnight. This example proves that process selection as well as facility layout have strategic significance and has long-term impact to the entire organization. So, what is a process? A process consists of all the operations that is combined to make a product, service. In short, it is a systematic way of doing things. What is process selection? Process selection refers to deciding on the way production of goods or services will be organized, and as we have learned from the Coca-Cola video, it has major implications for capacity planning, layout of facilities, equipment, and design of work systems. When is process selection needed? Process selection occurs when new products or services are being planned. However, it also occurs periodically due to technological changes in products or equipment, as well as competitive pressures. How an organization approaches process selection is determined by the organization's process strategy. Process strategy, therefore, is the organization's approach to transforming resources into goods or services. The key aspects of process strategy include capital intensity and process flexibility. Capital intensity refers to the mix of equipment and labor that will be used by the organization, whether the process is capital intensive or labor intensive. A process is said to be capital intensive if the firm is invested heavily on machineries and equipment. A process is labor intensive if most of its production processes is done by humans. Process flexibility, on the other hand, refers to the degree to which the system can be adjusted to changes in processing requirements due to such factors as changes in product or service design, changes in volume processed, and changes in technology. This answers whether equipment used can perform different functions, which means that processes are using general purpose equipment or equipment used are highly specialized. Process choice is demand driven. And there are three important questions in process selection. Number one, how much variety in products or services will the system need to handle? Number two, what degree of equipment flexibility will be needed? And number three, what is the expected volume of output? These questions are deemed important because variety, flexibility, and volume will dictate the appropriate process type. Take note of these three factors as we discuss the different types of processes later on. There are 5 major types of processes, and these include: number 1, job shop; number 2, batch processing; number 3, repetitive processing; number 4, continuous processing; and number 5, project. Let's start with job shop. A job shop usually operates on a relatively small scale. It is used when a low volume of high variety goods or services will be needed. Processing is intermittent, and work includes small jobs, each with somewhat different processing requirements. In a job shop, there is high flexibility. Using general purpose equipment and skilled workers are important characteristics of a job shop. Job shops are usually process-focused. A service example of a job shop includes dental clinic, a repair shop, or any medical clinic that can process a variety of patients and variety of illnesses. A manufacturing example of a job shop is a tool and die shop that can produce one-of-a-kind tools. Let us explore what is a tool and die, or what is a tool and die shop. What is a tool and die industry? According to the Department of Trade and Industry, the tool and die industry is an industry that uses general and specialized metal cutting technology to fabricate dies, molds, and toolings employed to convert raw material into a required shape. The common products of the sector includes dies, could be simple, compound, and progressive; molds, which is used for forging, plastic injection or blow molding; die casting, glass blow molding; and tools, example, jigs and fixtures used for cutting and shaping different materials. Molds are shaping implements for glass, metal, rubber, and plastic components through processes such as die casting, blow molding, and sheet stamping. Both molds and dies are used to give a material a final or intermediate shape. Thus, these products are found at the forefront of the shaping and fabrication industries. Tool and dies normally are ready-to-use products either as a standalone, such as molds, or as an attachment to a machine, such as a die. The products of the tool and die industry are typically made by mold and die makers using general, conventional, and specialized metal cutting technology like computer numerically controlled cutting machines or CNC, employing special tool steel materials which are either pre-hardened or which undergoes heat treatment after the desired tool has been cut to shape. The skill levels of mold and die makers are of the craftsman level, which requires talent, experience, although the use of CNCs improves the productivity of some. The next process type is batch. Batch processing is used when a moderate volume of goods or services is desired, and it can handle a moderate variety of products or services. The equipment needed need not be as flexible as in a job shop, but processing in batch still intermittent. The skill level of workers doesn't need to be as high as in a job shop because there is less variety in the jobs being processed, and examples of batch processing include bakeries, which make bread, cakes, or cookies in batches; movie theaters, which show movies to groups, which also considered batches of people; and airline, which carry plane loads of people from airport to airport, which is also considered as a batch. Other examples of products that lend themselves to batch production are paint, ice cream, soft drinks, beer, magazines, and books. The third type of process is repetitive. Repetitive is used when higher volumes of more standardized goods or services are needed. The standardized output means only slight flexibility of equipment is needed. Skill of workers is generally low, and examples of this type of system include production lines and assembly lines. In fact, this type of process is sometimes referred to as assembly line. In an assembly line, it usually uses modules or components previously prepared and assemble them in the final assembly area. Examples of repetitive processes are production of automobiles and production of appliances. This one here is an example of a capital-intensive assembly line for Tesla cars. Tesla car production is mostly done by machines using high-precision robots. The next process type is continuous processing. When a very high volume of non-discrete, highly standardized output is desired, a continuous system is used. Non-discrete goods or products are those that can be bought in any quantities other than positive integers. Examples are sugar, salt, oil. These systems have almost no variety in output, hence, no need for equipment flexibility. Workers' skill requirements can range from low to high, depending on the complexity of the system and the expertise of the workers needed. Generally, if equipment is highly specialized, worker skills can be lower. Thus, continuous production is product-focused or organized around the product. Examples of non-discrete products made in continuous systems include petroleum products, steel, sugar, flour, and salt. Continuous services include air monitoring, supplying electricity to homes and businesses, and the internet. These process types are found in a wide range of manufacturing and service settings. The ideal is to have process capabilities match product or service requirements. Failure to do so can result in inefficiencies and higher costs than are necessary, perhaps creating a competitive disadvantage. The next slide shows a summary of the different types of processes, their description, their corresponding advantages, and their corresponding disadvantages. So as you can see here, for job shops are usually customized. The advantages is they are able to handle a wide variety of work. Disadvantages is low, high cost per units, and it involves complex planning. I'll just leave this table for you to understand and study, since this has already been discussed in the previous slides. The next type of process is called project. A project is used for work that is non-routine with a unique set of objectives to be accomplished in a limited time frame. Examples range from simple to complicated, including such things as putting on a play, consulting, making a motion picture, launching a new product or service, publishing a book, building a dam, and building a bridge. Equipment flexibility and worker skills can range from low to high. So that's it for the different types of processes. If you have any question, just reserve your question during our consultation class this coming Saturday. Let us proceed to the next part or the next topic, which is process analysis and design. When analyzing and designing processes, we ask the following question. Is the process designed to achieve competitive advantage? Does the process eliminate steps that do not add value? Does the process maximize customer value as perceived by them? Will the process win orders? Process analysis and design is an important aspect in selecting the best process strategy. A number of tools help us understand the complexities of process design and redesign. They are simply ways of making sense of what happens or must happen in a process. Let's look at 5 of them. Number 1 is flowchart, number 2 is time function mapping, number 3 is value stream mapping, number 4 is process charts, and number 5 is service blueprinting. Let's start with flowchart. Flowchart is a schematic or drawing of the movement of material, products, or people. It is a graphical or symbolic representation of a process. Each step in the process is represented by a different symbols and contains a short description of the process step. Each step is linked together with arrows showing the process direction. Flowcharts provide a view of the big picture. So this is an example of a flow diagram or a flowchart. If I am not mistaken, this is flow diagram for assembly of Harley-Davidson motorcycle. So it starts from frame tube bending to frame building work cells to frame machining and hot paint frame painting. Then it goes down to the assembly line. The assembly line involves oil tank work cell, shocks and forks, handlebars, fender work cell, then wheel work cell, fuel tank, so on and so forth until the final product is shipped to the final consumer. That's why the last step found here is crating. I think, if I'm not mistaken, crating is putting all the products ready for transportation. The next tool is time function mapping. Time function mapping is similar to the flow chart, but it shows flows and time frame. This is sometimes called process mapping, and it also adds rigor and time elements. Let us look at an example of a time function map. This is an example of a comparison of a baseline and an improved time function map. Here, what we can see is a baseline function map. In the time function mapping, nodes indicate the activities. What we mean by nodes are the different activities like a product ordering, processing, waiting, printing until the final product is being received by the consumer. The arrows indicate the flow direction with the time on the horizontal axis, as you can see here at the bottom. As you can see in this slide, it took 52 days to complete a transaction from the time the customer placed an order up to the time the order was received. This type of analysis allows the users to identify and eliminate waste such as extra steps, duplication, delay, and in this example there is so much waiting time. Look at the initial steps, no? For ordering and processing the order. It took 12 days already, and it took another 13 days before the order was being printed, when in fact this cannot be done in a single day, no? So therefore, by looking at the baseline function map, we can already see that there is already room for improvement. Let us look at the next slide and see how the improved function map looks like. Okay, this is the improved function map, and in this illustration, no, we can already see the improvements in the process when wastes were eliminated, and it significantly reduced the processing time from 52 days to 6 days. So a whopping 46 days that is being saved, and that's 46 days improved processing time. As you can see here, it only took 3 days from the order was received until it was being printed. There's no more waiting time for the order before the orders are being extruded after the order has been printed, no? So this is the application or the use of the time function map in determining which of the process can be improved. The next one is called value stream mapping. A value stream mapping is a variation of the time function map. VSM or value stream map takes an expanded look at where value is added and not added in the entire production process, including the supply chain. As with the time function mapping, The idea is to start with the customer and understand the production process, but value stream mapping extends the analysis back to the suppliers. So as you can see here, it extends from the customers to the suppliers. Let's look at an example of a value stream map. This is an example of a value stream map that shows that the company received. In here, this example shows that the company received an order of 11,000 units per month, and they want to understand how the order was processed through manufacturing. So as we can see, there are 5 steps in the manufacturing process. Number 1 is the machine, component mounting, assemble, test, and then package. The value stream map helps in understanding its analysis beyond the organization by looking at both suppliers and consumers. In this mapping, we note that large inventories, that's 2,500 units, exist in incoming raw materials and almost between processing steps. Aside from that, we have also noticed that value added time is very low compared to the total number of days or time for the entire process. As you can see here, it only took 140 seconds for the value added time. There are only 140 seconds for the value added time, whereas there is 26 days processing time. No? So in here, to improve this process, one way, if you look at the inventory, one way to reduce materials inventory is to have deliveries twice per week rather than once per week. VSM takes into account not only the process but also the management decisions and information systems that supports the process. Then the next one is process charts. Process charts uses symbols, time and distance to provide an objective and structured way to analyze and record the activities that make up a process. They allow us to focus on value-added activities. So to help us understand a process chart, let's look at an example. This is the process chart for hamburger assembly process. So as you can see, it starts from meat patty in storage, transfer to broiler, then visual inspection, transfer to rack, then temporary storage, then obtain the buns, the lettuce, then assemble the order, and then place it in the finished rack. Okay. You have noticed that there are chart symbols here on the process chart. No? There's an inverted triangle, a letter D, a square, an arrow, and a circle. We will go back to this chart. For now, we will get to know first the symbols used in the process chart. Process charts uses the following symbols. Circle means its operations. A rectangle or a square means inspection. An arrow refers to transportation. D refers to delay. And the inverted triangle refers to storage. So let us go back to the process chart for hamburger assembly process in a fast food restaurant. So as you can see here, from the inverted triangle, you take out the meat patty from the storage, you transfer, so therefore there's an arrow, and then you put the patty in the broiler because you are going to cook the patty. So broiler or broiling here is an operation. Once it's done, you inspect whether it's already cooked, then you transfer it to the rack, then you also put it in the temporary storage, then you obtain the buns. No? You obtain the buns, it's transportation again, and then you go back to the circle, which is to assemble the order. Then you transport it to place it in the finished rack. Okay, in here we can also see the time element. Okay, there's a time element here, and this time element will show the total processing time for this hamburger assembly process. So as you can see here, the total time is 3.15 minutes In this process chart, it even includes the distance in feet, which is 3.5 feet for the entire processes. The value-added operations here only applies to operations. All the rest of the processes cannot be considered as value adding. There's no value adding in inspection, there's no value adding in transportation, and definitely there's no value adding in delay or in storage. So only the circle can be counted as value adding activities. So as you can see here, broiling, which is 2.50 minutes, and another 0.20 minutes for the assembly, for a total time of 2.70 divided by 3.15. Therefore, the value adding time, okay, the value added time in this case is only 85.7%. So as you can see here, this is the application of the process chart in determining how much time is value added, and also to identify how the company or how the business will be able to improve this particular hamburger assembly process. Then the next one is service blueprinting. Recall that we have discussed service blueprinting under the design of goods and services in the previous lesson. To recap, service blueprinting is a process analysis technique that focuses on the customer and provider's interaction with the customer. This is an example of a service blueprint. Service blueprint for service at 10-Minute Lube Incorporated. If I am not mistaken, this is for a car wash business. So this all the same in our discussion in the previous chapter. The service blueprint is divided into 3 levels: level 1, level 2, level 3. Level 1, these are under the control of the customer. In the second level, these are activities of the service provider interacting with the customer. And the third level includes activities that are performed away from and not immediately visible to the customer. Each level suggests different management issues. For instance, the first level may suggest educating the customer or modifying expectations, perhaps through advertising and promotion. In the second level, on the other hand, may require focus on personnel selection and training, while on level 3 may focus more on process improvement and innovation. This service blueprint here also notes potential failure points, which is important because the consequences of this failure points can be greatly reduced if identified at the design stage, when modification or appropriate poka-yoke can be included. Poka-yoke are fail-safe quality approaches to ensure fewer failure in product performance or service delivery. We will discuss more of this under quality management. In this example, a time dimension can also be included to aid understanding, extend insight, and provide the focus to customer service. So that's it for process selection. Again, reserve your questions during our consultation session this coming Saturday. So let me proceed to the next topic, which is facility layout. Before I will proceed, I assume that you have already seen the video on the Mad Cafe design. No? In that video, we were given a glimpse of how they organize anything inside their cafe, and we will jumpstart our discussion on facility layout on the Mad Cafe design. Layout refers to the configuration of departments, work centers, and equipment with particular emphasis on movement of work, customers, or materials through the system. It could also mean the physical arrangement of equipment, offices, rooms, and the like within an organization. It also describes the location of resources and their relationship to each other. Layout, therefore, is deciding where to put all the facilities, machines, equipment, and staff in the operation. Why is facility layout important? As in other areas of system design, layout design are important for three basic reasons. They require substantial investment of money and effort. They involve long-term commitments which makes mistakes difficult to overcome, and they have a significant impact on the costs and efficiency of operation. The need for layout planning arises both in the process of designing new facilities and in redesigning existing facilities. The most common reasons for redesign of layouts include inefficient operations, such as high costs or bottlenecks. We will discuss what are bottlenecks when we come to capacity planning, accidents or safety hazards, changes in the design of products or services, introduction of new products or services, changes in the volume of output or mix of output, changes in methods, changes in equipment, changes in environmental or other legal requirements, and some moral problems such as lack of face-to-face contact. Take note that poor layout design can adversely affect system performance. The basic objective of layout design is to facilitate a smooth flow of work, material, and information through the system. The supporting objectives of layout design generally involve the following: facilitate attainment of product or service quality, use workers and space efficiently, again to avoid bottlenecks, minimize material handling cost, eliminate unnecessary movement of workers or materials, minimize production time or customer service time, design for safety. To summarize, the objective of facility layout is to achieve desired output or maximum output using minimum resources. Layout design, therefore, aims to organize the physical arrangement of facilities so that operations run as efficiently as possible. Di lang day na pagpagwapa lang. Di lang na kay tungod kay mo ingon sa feng shui na ingani ang itsura sa imo ang layout sa imong tindahan o sa imong restaurant, but design for your layout is needed para there will be an efficient operation of your business. Here are the different types of layout. Number 1 is product, number 2 is process, number 3 is fixed position, then cellular production or work cells, then warehouse or storage layout, and lastly, retail layout. Let us discuss product layout first. And when I discuss product layout, think what could possibly be the different types of processes that will be suitable for product layout, what type of processes that will be suitable for the process layouts. Product layouts are used to achieve a smooth and rapid flow of large volumes of goods or customers through a system. This is made possible by highly standardized goods or services that allow highly standardized repetitive processing. Now you have already an idea, no? The work is divided into a series of standardized tasks permitting specialization of equipment and division of labor. The large volumes handled by these systems usually make it economical to invest substantial sums of money in equipment and job design. Because only one or a few very similar items are involved, it is feasible to arrange an entire layout to correspond to the technological processing requirements of the product or service. Hence, it is called a product layout. For instance, if a portion of a manufacturing operation required the sequence of cutting, sanding, and painting the appropriate pieces of equipment would be arranged in that same sequence. And because each item follows the same sequence of operations, it is often possible to utilize fixed path material handling equipment such as conveyors to transport items between operations. The resulting arrangement in product layout forms a line, and in manufacturing environments, the lines are referred to as production lines or assembly lines. Product layout achieve a high degree of labor and equipment utilization, which tends to offset their high equipment cost. Because items move quickly from operation to operation, the amount of work in process is often minimal. Consequently, operations are so closely tied to each other that the entire system is highly vulnerable to being shut down because of mechanical failure or high absenteeism. This is an example of an assembly line or a production line. So as you can see, there are 4 stations: Station 1, Station 2, Station 3, Station 4, and there are different types of work or tasks performed in each stations. And most often, each station, could be raw materials or labor input in every station in order to accomplish the task. No? But in the case of Tesla, as you can see in the previous slides, Tesla does not use labor anymore. But instead, Tesla uses robots to assemble their cars. Another example is the Boeing factory, the Boeing assembly line, or the assembly line for the Boeing aircraft. And I hope that at this point, you have already seen the Boeing video I have sent through the GC. In that video, we have seen that final assembly happens in one of the factories of Boeing, and final assembly resembles that of a line where components are added in its workstation until the finished product is completed, after which final testing will be conducted. No? Can you imagine how big this factory would be in order to house the number of aircraft that is being assembled in this assembly line or in this factory of aircraft? So the following are some of the advantages of product layout. So number 1 is high rate of output, low unit cost due to high volume. The high cost of specialized equipment is spread over many units. Labor specialization, which reduces training costs and time and results in a wide span of supervision. There's also low material handling cost per unit. Material handling is simplified because units follow the same sequence of operations. Therefore, material handling is often automated. There's high utilization of labor and equipment, and fairly routine accounting, purchasing, and inventory control. The crucial part of product layout is how to balance the line. If you remember the Boeing video, it took them 9 days only to assemble the final Dreamliner products of Boeing. So dapat within 9 days mahuman jud na. So dapat klaro jud na unsa may trabaho sa station 1, station 2, and so on and so forth, para mahuman jud nila na og 9 days nga wala sila backlog, wala pud sila daghang sobra nga trabaho ang ubang workstation. So the technique for that is called line balancing. So the goal of product layout is to arrange workers or machines in the sequence that operations need to be performed. The sequence is referred to as a production line or an assembly line. These lines range from fairly short, with just a few operations, to long lines that have large numbers of operations. The process of deciding how to assign tasks to workstation is referred to as line balancing. The goal of line balancing is to obtain task groupings that represent approximately equal time requirements. This minimizes the idle time along the line and results in a high utilization of labor and equipment. Idle time occurs if task times are not equal among workstations. Some stations are capable of producing at higher rates than others. These fast stations will experience periodic waits for the output from slower station, or else they will be forced into idleness to avoid build-up of work between stations. Unbalanced lines are undesirable. No? Unsa man ang unbalanced line? Kana bang ang ubang station dali mahuman, ang ubang station dugay mahuman. No? Unbalanced lines are undesirable in terms of inefficient utilization of labor and equipment. Ngano man, kay kung ang uban sa mahuman, ang uban mo panahuman, kapudyo na magbagdoy-bagdoy na naman itong mga uban, mag-cruise stage na naman kay wanay trabaho, no? So, manang dapat, kung 8 hours ang trabaho, dapat tanan sa kada workstation 8 hours ang trabaho. And because this inefficient utilization of labor can also create morale problems sa slower station for workers who must work continuously. No? Lines that are perfectly balanced will have a smooth flow of work. As you notice sa Boeing, smooth kayo ang flow sa ilang work. Kay bawo sila sa mga trabaho kada station. No? Lines that are perfectly balanced will have a smooth flow of work as activities along the lines are synchronized to achieve maximum utilization of labor and equipment. The objective is to minimize the imbalance between machines or personnel while meeting required output. Line balancing, therefore, involves assigning tasks to workstations. Here are the steps in line balancing. Number 1, you start with the precedence relationship by creating a precedence diagram. Number 2 is you determine the cycle time. Number 3, calculate the theoretical minimum number of workstation. And number 4, you balance the line by assigning tasks to workstations. Let's discuss one by one. Precedence diagram is a very useful tool in line balancing. What is precedence diagram? It is a diagram that shows elemental tasks and their precedence requirements. It visually portrays the tasks that are to be performed along with the sequential requirements, that is, the order in which tasks must be performed. Let us illustrate this concept with an example. Suppose that Boeing wants to develop a precedence diagram for a wing component that require a total assembly time of 66 minutes. The tasks corresponding task time and the task relationship are listed below. So for instance, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 tasks from A to I. The performance time are as follows: 10 for A, 11 for B, 5 for C, 4 for D, 12 for E, 3 for F, 7 for G, 11 for H, and 3 for I, which gives us a total task time for 66 minutes. The precedence relationship are as follows. Station B follows Station A, Station C and D follows Station B, E also follows Station A, F follows stations C and D, follows Station C and D, Station G will follow Station F, Station H will follow Station E, and Station I follows Station G and H. So you can see here, as an example, both B and E have the same precedent task, which is task A. This means that tasks B and E cannot be done until task A has been completed. Para sa guna ninyo ba, di pwede mag-accounting tugwa panahon manong accounting 1. Okay. So ang first step sa line balancing is to group tasks into job stations to meet the specified production rate in the form of a precedence diagram. This diagram helps structure an assembly line and workstation and makes it easier to visualize the sequence of tasks. So as you can see here, so this is how you're going to make a precedence diagram. You just make a visual image of this table. A precedence diagram is a visual image of this table, wherein you make a drawing of the sequence of the task so that you know how the work is done from A to I. So example, starts with A is being followed by B and E. A has 10 minutes, B has 11 minutes, and E has also 12 minutes. C and D, so you can see here, C and D follows task B, while task F follows task C and D as being indicated in this precedence relationship here. And then G follows station F. Ang E pod, ni sunod po siya sa A. Ang sunod sa E, task E, mao na ang task H. Ug lastly, task I follows task G and H, and I will now be the final task. Okay? This diagram is read from left to right. So the initial tasks are on the left and the final tasks is on the right. This diagram helps structure an assembly line and workstation and makes it easier to visualize the sequence of tasks. This is step 1. You create a precedence diagram. The next step is to determine the cycle time. Okay? Why? Because the primary determinant in the lines, in line balancing, is the line's cycle time. What is cycle time? Cycle time is the maximum time allowed at each workstation to perform assigned task before the work moves on. Okay? The cycle time also establishes the output rate of a line. For instance, if the cycle time is 2 minutes, units will come off at the end of the line at the rate of 1 every 2 minutes. Hence, the line's capacity is the function of the cycle time. Okay, kung 2 minutes ang cycle time, so every 2 minutes usaray output. So therefore, if there are 60 minutes, 30 ra ang output mo na capacity sa usa ka oras sa kadto nga line because the cycle time is 2 minutes. Let's expand our example. Suppose that the work required to fabricate a certain product can be divided up into 5 elemental tasks with task times and precedence relationship in the following diagram. So for instance, task 1 has 1 minute, task 2 has 0.7 minutes, task 3 has 1 minute, 0.5 minutes for task 4, and 0.2 minute for task 5. The task time govern the range of possible cycle time. The minimum cycle time is equal to the longest task time, which is 1 minute, okay, this one here, which is task 3, and the maximum cycle time is 2.5 minutes, which is the sum of the task time. That's 0.1 plus 0.7 plus 1 plus 0.5 plus 0.2. Okay, that is your maximum cycle time of 2.5 minutes. The minimum cycle time would apply if there were 5 workstations. The maximum cycle time would apply if all tasks were performed at a single workstation. Why is it important that we know what is the minimum, what is the maximum, or what is the correct cycle time? Because the minimum and maximum cycle times are important because they establish the potential range of output for the line, which can be computed using the following formula. Output rate equals to operating time per day divided by cycle time. So if one day has 480 minutes, and cycle time is 1 minute, your output rate would be 480 units per day. However, if your cycle time is 2.5 minutes, the output would be 192 units. That is 480 minutes divided by 2.5 minutes per unit. As a general rule, the cycle time is determined by the desired output. That is, a desired output rate is selected. Dapat mag-select daan o pila may desired output rate nimo everyday para makakompute ka pila may imong cycle time. So therefore, ang formula sa cycle time is equal to available time per day or total operating time per day divided by the desired output. So if there are 8 hours available time a day, that would be 480 minutes per day. And if the desired output rate is 480 units per day, therefore, cycle time in this operation is 1 minute per unit. Let us apply this concept to the Boeing problem. So, to continue, on the basis of the precedence diagram, Boeing determines that there are 480 productive minutes of work available per day. The production schedule requires that 40 units of wing component be completed as output for assembly line each day. So it's clear in the Boeing problem that there are 8 hours, which is equal to 480 minutes of work per day, and the required output rate is 40 units of wing component every day. Therefore, in this problem, cycle time is 12 minutes per unit. Okay, how? This is computed by dividing 480 minutes by 40 units. So we are done with step number 2, which is computing for the cycle time. The third step is computing for the theoretical minimum number of workstations. The number of workstations that will be needed is a function of both the desired output rate and the ability to combine elemental tasks into workstation. We can determine the theoretical minimum number of workstations to provide a specified rate of output as follows. The n-min, or the theoretical minimum number of workstation, is equals to the summation of small letter t over cycle time. N-min is the theoretical minimum number of workstation, and the summation of t is the total task time. To continue with the Boeing example, our theoretical minimum number of workstation is computed by dividing 66 minutes with 12 minutes. 66 minutes, if you recall, is the total task time, and 12 minutes is the cycle time, which we computed in the previous step. This will give us 5.5 stations, but this is not possible. So therefore, our workstation is approximately, our theoretical minimum number of workstations is roughly equal to 6 stations. Take note, however, that this is the minimum number of workstations. Therefore, the number of workstations should not be below 6 stations but could go higher. The last step is to balance the line by assigning specific tasks to workstation. Now let's see how a line is balanced. This involves assigning tasks to workstations. Generally, no technique are available that guarantee an optimal set of assignment. Instead, managers employ heuristic or intuitive rules which provide good and sometimes also optimal set of assignments. The most common line balancing method involves assigning tasks in order of most following tasks and assigning tasks in order of greatest positional weight. Positional weight is the sum of each task time and the times of all the following tasks. So to help us understand, let's complete our line balancing for the Boeing component. This is our original, which we don't know which task will be assigned to a particular workstation. Okay, take note, there are 2 important considerations that we are looking at. Number 1, the theoretical minimum number of workstation, which is 6, and cycle time, which is 12 minutes. So let's begin with task A. Task A has 10 minutes. So kung imong i-minus ang 10 sa 12, 2 minutes na lamang mabilin. Ang nagsunod sa A, B, ug E. Ang B na 11 minutes, ang E na ay 12 minutes. So therefore, dili nimo pwedeng ibutang ang A ug B in one station or ang A, B ug ang E. Dili nimo pwedeng ibutang og one station. Likewise, di po nimo pwedeng ibutang og one station ang B ug ang E into one kay mula pa sila sa cycle time which is only 12 minutes. So therefore, para mahimo ng posible, atong ibutang into one workstation ang A, ang B, ug ang E. But we will come to E later on. Let's proceed lang sa C, sa D, ug sa F. Kung atong tan-awon, ang A, station 1 siya, kay siya ang pinakauna sa step, ug ang tanang task nga mosunod, dependent niya. Dili, walay mo proceed na trabaho kung walay mahuman si A. Okay? So, ang mahitabo, atong tan-awon, ang C, ang D, ang F, ug ang G, kay sumpay man sila linya. Lahi o na itong tanaw si E ug si H, kay lahi po siya og linya sa trabaho. So as you can see here, the total task time, the combined task time for C, D, and F is 5 plus, that's 12 minutes. So therefore, we can actually put, by looking at the relationship and the following tasks, we can actually put stations, or rather tasks C, D, and F to one station and task E to another station. Okay? In this case, station 4 and station 3 can actually be interchanged. Pwede si task E maibutang nimo sa station 3 and pwede og si C, D, ug F ay maibutang sa station 4. Kung imong tanaw ng sunod, automatically station H ibutang nimo into one station kay 11 minutes, 1 minute na lang may diferensya sa 12 minutes. And lastly, ang imong last station is station G and E, which is actually equal to 10 minutes. Pasok gihapon ka sa imong 12 minutes nga task time or cycle time rather. Okay? After di mo assign sa mga task ngadto sa mga workstations, pwede na kang mag-compute sa efficiency o sa idle time percentage. In this case, efficiency is computed as the summation of task time over N times CT. N refers to the number of workstations. In this case, there are 6. So we multiply 6 by 12 minutes, we get 72. And we multiply 6 by 12, we get 72 minutes. And the total task time from the table, we have 66 minutes. Therefore, multiply this by 100. Efficiency for this line is 91.7%. Sa yun na pag-compute sa idle time, i-minus lang nato ang efficiency from 100%. So therefore, that's 100% minus 91.7%. And for this improved product line, or for this balanced line, idle time is equal to 8.3%. So I hope you understand this one, and to facilitate more your understanding on this topic, there will be an assignment. Okay, this is included in the module, and this is already uploaded in our Canvas site. So just read the assignment. Due date for this assignment is on Saturday at 8 o'clock in the morning. That's November 7, prior to the first class, no, in that karong Sabado for section A and section B. Again, reserve your question for our consultation session on Saturday, November 7. Okay, so let us proceed to the next type of layout, process layout. Process layout is a layout that deals with low volume, high variety production in which like machines and equipment are grouped together. The layouts feature departments or other functional groupings in which similar kinds of activities are performed. A manufacturing example of a process layout is the machine shop, which has separate departments for milling, grinding, drilling, and so on. Items that require those operations are frequently moved in lots or batches to the departments in a sequence that varies from job to job. Process layouts are designed to process items or provide services that involve a variety of processing requirements. The variety of jobs that are processed requires frequent adjustments to equipment. This causes discontinuous workflow, which is referred to as intermittent processing. The variety of jobs that are processed requires frequent adjustments to equipment. Consequently, variable path material handling equipment such as forklift trucks, jeeps is needed to handle the variety of routes and items. The use of general-purpose equipment provides the flexibility necessary to handle a wide range of processing requirements. Workers who operate the equipment are usually skilled or semi-skilled. Process layout are quite common in service environment. Examples include hospitals, colleges and universities, banks, auto repair shop, airlines, and public libraries. For instance, hospitals have departments or other units that specifically handle surgery, maternity, pediatrics, psychiatric, emergency, and geriatric care. And universities have separate schools or departments that concentrate on one area of study such as business, engineering, science, or math. Because equipment in a process layout is arranged by type rather than by processing sequence, the system is much less vulnerable to shutdown caused by mechanical failure or absenteeism. In manufacturing systems especially, idle time equipment is usually available to replace machines that are temporarily out of service. Moreover, because items are often processed in batches, there is considerably less interdependence between successive operations than with the product layout. So this is an example of a process layout in an emergency room of a hospital. So there are two types of patient here, if I'm not mistaken. Number one is a patient with a broken leg. So the first one is the triage room or the emergency room. Then from the emergency room, it will proceed to the radiology to check the broken leg. From radiology, it will go to surgery. From surgery, it will proceed to the AR beds, then pharmacy, then billing or exit. Then another patient is a patient with an erratic heart pacemaker. Kung anong pacemaker, ibutang na sa kanang mga tao nga hinay ang ilang heartbeat. Ang ilang heartbeat is below below the normal heart rate, no? So ang pacemaker na siya battery, no? Mag-erratic ng kani ang pacemaker, that means palobat na siya, no? So mag-undergo na po another operation kay mag-change ang battery ang pacemaker. So patient B, usually diretso na siya sa ER. From the ER, diretso na siya sa surgery kay na naman siya history, na siya record ang hospital sa patient. So from surgery, diretso sa pharmacy, then i-lab kung okay na, we proceed to the laboratories, then go to the ER beds for recovery. Then pag okay na, pwede na sa muli, pwede na exit. So as you can see, common sa process layout is tapad-tapad ang mga stations nga dunay daghang volume of movement between people. So we will understand how to do that later on. The main issue in designing process layout concerns the relative positioning of the departments involved. The problem is to develop a reasonably good layout. Some combinations will be more desirable than others. Layouts can also be influenced by external factors such as the location of entrances, loading docks, elevators, windows, and areas of reinforced flooring. Also important are noise levels, safety, and the size and locations of restrooms. When designing process layout, the most common tactic is to arrange departments or work centers so as to minimize the costs of material handling. In other words, departments with large flows of parts or people between them should be placed next to one another. Material handling costs in this approach depend on number one, number of loads or people moving between departments, and number two, the distance of loads or the distance related cost of moving loads or people between departments. Cost is assumed to be a function of distance between departments. So it is the sum from this formula. Cost is the sum of the product of the volume of load between departments multiplied by the cost to move a load between departments. Thus, the cost can be computed using this formula. No? Basta, muna yung formula. Ang N, kaya nasa ibabaw sa summation, it refers to the total number of work centers or departments. Then, letter I and letter G are the individual departments. So, X, I, G would be the number of loads moved from department. No? Simple lang class, imo lang i-multiply ang number of loads nga i-move between department and the cost of moving the cost of moving the load between departments. And after you get the product, you simply add the product to get the total cost. So, para masabdan nato niya, kanatag problem. We are going to arrange 6 departments in a factory to minimize the material handling cost. Each department is 20 by 20 feet and the building is 60 feet long and 40 feet wide. The first step in process layout is to construct the from to matrix, showing the flow of parts and materials from department to department para mahibawan nimo pila man kadaghan na ang i-transfer or pila man ka transaction between departments. So from here, kita nimo nga from assembly to painting 50 units, assembly to machine shop 100 units, and assembly to testing is 20 units. So from painting to machine shop 30 units, painting to receiving 50 units, painting to shipping 10 units, and then machine shop to receiving 20 units, and machine shop to testing, that's 100 units, and receiving to shipping is 50 units. Okay, the high flow of load between 1 and 3 and between 3 and 6 are immediately apparent here. Departments 1, 3, and 6 therefore should be put closer to each other. Take note that in this problem, there are no restrictions in the physical layout of departments. In other words, each department's location is interchangeable. Step 2 is to determine the space requirement. Actually, this is optional, but if this is not required in the problem, there's no need to create this step. But for purposes of illustration, the next step is to determine the space requirement. Okay, think of this as a starting initial layout. Our goal is to improve this layout if possible. Then, we are going to develop an initial schematic diagram showing the sequence of department through which parts move. It always boils down to a layout, or a diagram, or a drawing of the existing layout. So from station 1, this is station 2, and there are 50 units between 1 and 2. There are 30 units between 2 and 3, and 100 units between 1 and 3. Another 20 units between 1 and 6. That's 50 units between 2 and 4 rather. 10 units between 2 and 5. 20 units between 3 and 4. 100 units between 3 and 6. 50 units between 4 and 5. So we are now ready to compute for the costs. But as you can see here now, this shows that 100 loads move weekly between 1 and 3, between 3 and 6. So ato ning utrohon ang layout para mo-minimize ang atong cost na natayhin nga dapat ang 1 iduol nimo sa 3 ug dili nimo dapat iladyo ang 6 sa 3. Next na step is ato sang computon pila may total cost aning atong original na layout. So first, there is an additional information here or additional assumption in this problem that a forklift carries all interdepartmental loads. So the cost of moving one load between adjacent department, so adjacent department kadtong 1 and 2, 2 and 5, ang estimated cost is $1. Moving a load between non-adjacent departments, so non-adjacent department katong between 1 and 6, 1 and 3, between 3 and 4, ang cost pag non-adjacent department is $2. So therefore, kay tapad man ng 1 and 2, that's 50 times 1, that's 50. Tungod kay non-adjacent man ng 1 and 3, and then 100 man ng load, that's 100 times 2, mo nang nahimong 200. Ang load between 1 and 6 is non-adjacent man ng 1 and 6, that's 20 times 2, that's 40, and so on and so forth. So the total cost for the original layout is 570. This is step 4. Step 5 is i-rearrange na to ang layout using trial and error, or in advanced systems, they are actually using computer software to rearrange the layout no? Taking into consideration some restrictions and other inputs. But for now, trial and error lang ta, kay wala man tay computer software. So, nanatay clue, dapat itapad ang 1, 3, ug 6 kay 100 man ang load, and so on and so forth. So, this is our improved layout. So, 1, 3, 6. So, the loads between these departments are 100. Tapad na tanan. Wala na non-adjacent department. All departments are adjacent to each other. So, the last step is to recompute the cost. So, the total cost for this rearranged layout is now reduced to 430 from 570. Okay, and the final step would be to present now the final layout of the different departments, taking into consideration the 40 feet and the 60 feet configuration. But then again, in the exams, these are not necessarily needed, but this is just presented for purposes of illustration. So at this point, there is an exercise. The exercise is not actually graded. The exercise rather is graded, but this is meant only for you to practice the problem. I have not given a deadline, but would appreciate that if you can submit the exercise still on Saturday, that would be good. But if not, okay lang sad, basta submit lang sad mo before mahuman ang atong semester. Aron ma-practice mo saan pag-apply ang concept sa paghimo og process layout. The next type of layout is fixed position layout. Before that, siguro na may idea no kung unsa nga klase nga process ang pwede sa product layout o unsa nga types of processes ang pwede sa process layout. So the third type of layout is fixed position layout. In fixed position layout, the item being worked on remains stationary and workers, materials, and equipment are moved about as needed. Almost always, the nature of the product dictates this kind of arrangement, such as weight, size, bulk, or some other factor, makes it undesirable or extremely difficult to move the product. Thus, product remains in one place, workers and equipment come to the site. Fixed position layouts are used in large construction projects such as buildings, power plants, dams, shipbuilding, and production of large aircraft and space mission rockets. The techniques for addressing the fixed position layout are complicated by three factors. First, there is limited space at virtually all sites. Second, at different stages of a project, different materials are needed. Therefore, items become critical as the project develops. Third, the volume of materials needed is dynamic. For example, the rate of use of steel panels for the hull of a ship changes as the project progresses. The fourth type of layout is cellular production or work cells layout. Cellular production is a type of layout in which workstations are grouped into what is referred to as a cell. Groupings are determined by the operations as needed to perform work for a set of similar items or part families that require similar processing. The cells become in effect miniature versions of product layout. The cells may have no conveyorized movement of parts between machines or may have a flow line connected by a conveyor. All parts follow the same route, although minor variations are possible. These are examples of work cells layout. So in the current layout, workers in small closed areas, they cannot increase output without a third worker and a third set of equipment. In the improved layout, cross-trained workers can already assist each other. They may be able to add a third worker as additional output is needed. Another example, in the current layout, straight line makes it hard to balance tasks because work may not be divided evenly. In the improved layout, such as the U-shape, workers have better access, and the 4 cross-trained workers were now reduced to 3. U-shaped work cells may reduce material and employee movement and space requirement while enhancing communication, reducing the number of workers, and facilitating inspection. The fifth type of layout is warehouse and storage layout. Warehouse layout is a design that attempts to minimize total cost by addressing trade-offs between space and material handling. Hence, the objective of this type of layout is to obtain the optimum trade-off between handling cost and cost associated with warehouse space. Consequently, management task is to maximize utilization of the total cube of the warehouse. That is, to utilize its full volume while maintaining low material handling cost. Material handling costs are all costs related to the transaction. This consists of incoming transport, storage, outgoing transport of the materials to be warehoused. These costs include equipment, people, material, supervision, insurance, and depreciation. Lastly, retail layout. Retail layout is an approach that addresses flow, allocates space, and responds to customer behavior. They are based on the idea that sales and profitability vary directly with customer exposure to products. Thus, most retail operations managers try to expose customers to as many products as possible. Studies show that the greater the rate of exposure, the greater the sales and the higher the return on investment. Thus, the goal in retail outlet is to maximize profitability per square foot of floor space. There are 5 ideas that are helpful for determining the overall arrangement of many stores. Number 1, locate the high-draw items around the periphery of the store. No? Ikatag di ay. No? Kanang mga pangitaonon sa tao, ikatag para masuroy sila sa tindahan. Okay? Next, use prominent locations for high impulse and high margin items. Again, use prominent locations for high impulse and high margin items. No, kanang sayon tuoron, kanang dali pangitaon. Next, distribute power items or items that may dominate a purchasing trip to both sides of an aisle and disperse them to increase the viewing of other items. So, di kanang mga power items, kanang mga halinon ba, dili na pwede nimo ibutan ka sa ka location. Imo na silang ikatag para makitaan pod ang ubang items nga di halinon para makapalit pod. Next, use end-eye location because they have a very high exposure rate. No? Mga tumoy-tumoy sa mga aisle, nadyo na ipamutang mga gagmay, mga boxes, labi na mga dili na kadyo mahalin anong paliton sa mga mamalitay. Convey, and lastly is convey the mission of the store by carefully selecting the position of the lead-off department. So that's all for process selection and facility layout. I hope you have learned something. And if you have questions or clarifications, please reserve them for our consultation session this coming Saturday. I will just post an announcement in our group chat for our schedule and for the Zoom details. So that's it, class. Thank you. Stay at home and stay safe, and God bless always.